If you want to solve an equation with a logarithm in it, one of the number one strategies is to get a single log by itself. So there's a 1 log, not a 2 in front, just one logarithm. And as soon as you have that 1 log by itself, you're going to change to exponential form. So the way I've explained that is to change from exponential form, the base number that I call the beaver, it tunnels under, the log falls in, so the only thing I have left is the argument. And then the beaver here, the base, gets raised to this side. Okay, so I'm just like, oh, use the beaver. Here we go, let's use the beaver. So I'm going to tunnel under, and when we tunnel under, the 2 comes under there. So the only thing I'm going to have left on the other side is negative 3x plus 4. And then on this side, I'm going to have 2 to the power of 4. Now I'm going to solve this algebraically. So let's evaluate 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then finish undoing the order of operations. So I'm going to get rid of adding 4 by subtracting 4. So that'll make that 12. Then I'm going to divide by negative 3, and I get negative 4. But the other thing that you want to keep in mind is if your original equation has an x in the denominator, we're worried about dividing by 0. If it has an x underneath an even root, we're worried about taking the square root of a negative, no real solutions. And when it comes to logarithms, you cannot take the log of 0 or a negative number. So in each of those cases, checking is not optional. So I'm going to take negative 4, I'm going to put it back into the original. Negative 3 multiplied by negative 4 is positive 12. Positive 12 plus 4 is 16. So I will be taking the log of a positive number, so I know that this answer is okay. But if I substitute negative 4 back into the negative 3x plus 4 and I get the answer 0, or I get a negative number, then I would have to throw this out. It's called an extraneous solution, fancy word for extra solution, in other words, not a solution. You throw it out and I would say no solution. But in this case, we're good. So single log, the 2 tunnels under, we've changed to exponential form, finish solving algebraically, and always check your answer.